Welcome to Tech Curiosity Stream. Today we're diving into artificial intelligence and machine learning, AI and ML. These aren't just tech buzzwords, they're changing how we live, work, and play. If you're new, hit subscribe and ring the bell so you never miss an episode. AI isn't just sci-fi robots or something only PhDs understand. At their core, these concepts are intuitive and surprisingly cool. My goal? Peel back the complexity and show you how AI and ML already shape your world. By the end, you'll see AI everywhere and understand it. Let's jump in. Why care about AI and ML? Imagine if electricity was just invented. AI is that level of game changer. It powers everything from healthcare breakthroughs to your favorite playlists. AI lets computers do things we thought only humans could: understand language, recognize faces, even create art. It's already in your phone, your smart speaker, your email filters, working quietly in the background. And this is just the beginning. Its potential is nearly limitless. Understanding AI means understanding the future. The more we know, the better we can shape where this tech goes, ethically and creatively. AI isn't just for techies, it's for anyone curious about tomorrow. Here's our roadmap. First, we'll break down what AI and ML actually mean. No jargon, just simple analogies. Next, a quick history lesson, how we got from wild ideas to today's smart tech. Then, we'll see how AI and ML work in your daily life. Recommendations, navigation, smart assistants. Finally, we'll zoom out to the big picture. The benefits, the challenges, and what's next. It's a packed episode, but you'll leave with a clear, practical understanding. Let's start with the basics. When you hear AI, you might picture movie robots, but real AI is much broader. AI is about building machines that can do things requiring human intelligence, like understanding speech or recognizing patterns. Think of AI as an umbrella term for all efforts to make machines smart. Most AI today is narrow AI. Specialists at one task, like recommending videos or playing chess. The dream is general AI, machines as flexible and creative as humans. But we're not there yet. For now, AI is a collection of powerful tools, each excelling in its own domain. It's the parent concept, the quest to make machines smart. Now let's see how we're actually making that happen. Enter machine learning, ML, the main way we build smart machines today. If AI is the goal, ML is the method. Teaching computers to learn from data, not just follow hard-coded rules. Instead of programming every detail, we feed the computer tons of examples, like showing it thousands of cat photos. The ML model finds patterns and learns what makes a cat, just like a child learns by seeing. This approach powers everything from stock predictions to voice recognition. ML is flexible, powerful, and behind most of the AI you use daily. The magic? It learns from experience, not just instructions. That's why AI feels so smart now. Here's the key difference. Old-school programming is like learning to ride a bike by reading a physics textbook. Impractical. Machine learning is learning by doing. Trial, error, and experience. ML models adjust and improve as they see more data, just like you get better at biking the more you ride. This implicit learning lets ML tackle problems too complex for explicit rules, like translating languages or recognizing art. AI is the quest to make computers smart. ML is the tool that learns from examples. This shift from rigid rules to learning from data is the breakthrough behind today's AI revolution. It's why your phone understands you and your apps feel personal. That's the power of machine learning. We know what AI and ML are, but where did the idea come from? The dream of creating artificial intelligence is ancient, found in myths and legends. Greek myths told of mechanical servants. Tales of the golem showed humanity's fascination with non-human intelligence. Centuries later, mathematicians laid groundwork for computer science. Charles Babbage designed mechanical calculators, proving machines could perform logic. In 1950, Alan Turing asked, "Can machines think?" He proposed the Turing test. A judge converses with a human and a machine. If they can't tell which is which, the machine passes. Turing ignited a generation of scientists. The stage was set for AI's birth. If Alan Turing lit the spark, a summer workshop in 1956 was the explosion that started the fire. Scientists gathered at Dartmouth College for an 8-week brainstorming session. The proposal was the first to use the term artificial intelligence. John McCarthy defined the goal as making machines use language, solve problems, and improve themselves. The attendees were the founding fathers of AI. They believed every aspect of intelligence could be precisely described so a machine could simulate it. Out of this workshop came the first AI programs. One, the logic theorist, proved mathematical theorems. Attendees established AI labs at universities like MIT and Stanford. They laid the foundations for everything that would follow, proving the quest for AI wasn't just a fantasy. After the initial hype, reality began to set in. The early promises of AI had been so grand that it was almost impossible to live up to them. Progress slowed and funders grew skeptical, leading to the AI winter. Funding dried up and the term artificial intelligence became a dirty word. Researchers tackled smaller problems like expert systems which proved commercially viable. This period taught that AI progress is deeply tied to computing power. The AI winter reflected the limitations of the technology at the time. A new spring was on the horizon. The AI winter thawed in the late 90s. This was due to computing power, the internet, and breakthroughs in deep learning. GPUs designed for video games were great at AI math. The internet led to big data. Researchers now had massive data sets to train machine learning models. Deep learning uses multi-layered neural networks to learn from data. With GPUs and big data, these models could finally be trained effectively. This led to rapid growth in AI capabilities. AI was back, more powerful than ever. Let's talk about how machine learning shows up in your life. Think about the last time you opened YouTube, Netflix, or Spotify. That personalized list of videos or songs is a powerful example of machine learning. It's a sophisticated AI at work, using data about what you've watched, skipped, or liked. The machine learning model dives into this data to find patterns, using a technique called collaborative filtering. The AI finds users whose viewing habits are similar to yours. Based on that, it makes an educated guess and recommends content to you. Every time you click on a video, you're providing feedback, giving the AI more data. This creates a continuous feedback loop where the algorithm is constantly learning. It's all designed to keep you engaged and watching. Let's move on to a piece of tech that's probably within arm's reach right now, your smartphone. Specifically, let's talk about the camera. 10 years ago, taking a great photo was all about the skill of the photographer and the quality of the lens and sensor. Today, a huge part of what makes your smartphone photos look so good is the AI working silently in the background. This is a field called computational photography, and it's basically using machine learning to overcome the physical limitations of a tiny phone lens. It's why your phone's camera can often compete with much larger, more expensive dedicated cameras. When you point your phone at something and press the shutter button, it's not just taking one picture anymore. In that split second, the phone might capture a burst of multiple images at different exposures. The AI then gets to work. It analyzes all those frames and intelligently merges them together. It takes the sharpest parts from one frame, the best colors from another, and the brightest highlights and darkest shadows from others. It's building a single, perfect image that's better than any of the individual shots. This is how features like HDR or high dynamic range work their magic, but it goes even deeper. Take portrait mode, for example. How does your phone know how to keep your face sharp while artfully blurring the background? That's a machine learning model that has been trained on millions of photos of people. It has learned to identify the outlines of a person, to recognize hair, glasses, and clothing. It creates a depth map, figuring out what's in the foreground and what's in the background, and then it digitally applies the blur. This is a complex task that used to require a big lens and a wide aperture, but now it's just a software trick powered by AI. And it doesn't stop there. There's AI for scene recognition, which automatically adjusts settings if it detects you're shooting a landscape versus a plate of food. There's AI that reduces the noise and graininess in your low-light photos. There's even AI that can recognize and tag the faces of your friends in your photo library. Every time you snap a picture, you are using a suite of sophisticated, specialized AI models that are all working together to help you take the best possible photo without you even having to think about it. It's a powerful creative partner right there in your pocket. Getting from point A to point B, apps like Google Maps or Waze use a complex AI system. It creates a real-time predictive model of the road network. It analyzes massive information flows to find the best path. This data comes from users like you, acting as real-time traffic sensors. The AI analyzes historical data and real-time input to predict traffic. This allows accurate ETAs, simulating the near future. The AI runs thousands of routes through its model, weighing traffic closures and turns. It proactively reroutes you based on new data, like accidents. It's an intelligent co-pilot, saving you time and frustration. For our final example, let's talk about talking to our devices. When you say, "Hey Siri, okay Google, or Alexa," and ask a question, you are initiating a conversation with a very sophisticated AI. This technology, known as natural language processing or NLP, is one of the most challenging and fascinating areas of AI. The goal is to give computers the ability to understand and respond to human language, both written and spoken, in a way that feels natural and intuitive. It's about bridging the gap between how we communicate and how computers process information. The first step is just hearing you correctly. An ML model has been trained on thousands of hours of spoken audio from a diverse range of people. It learns to filter out background noise and convert the sound waves of your voice into a string of text. This is called speech to text. But just having the words isn't enough. The AI then has to figure out what you actually mean. It needs to understand your intent. When you say, "What's the weather like in New York?" the AI has to recognize that you're asking for information, identify weather as the topic, and New York as the location. This is where deep learning really shines. The models analyze the structure of your sentence, the relationships between the words, and the context of your request. It learns that "play the new Taylor Swift song" is a command to start music, while "what's the new Taylor Swift song" is a request for information. This ability to parse grammar and semantics is what allows the assistant to understand a huge variety of questions and commands, even if they're phrased in ways it has never heard before. It's not just matching keywords, it's genuinely trying to comprehend the meaning behind your words. Finally, once it understands your request, it needs to find the answer and deliver it back to you. It might query a weather database, search the web, or access your calendar. Then it uses another AI model to construct a natural-sounding sentence and a text-to-speech engine to speak it back to you in a human-like voice. This entire, incredibly complex process, from sound wave to understanding to action to spoken response, happens in just a couple of seconds. It's a seamless orchestration of multiple AI and machine learning systems, all working together to make technology feel less like a tool and more like a helpful assistant. AI is woven into our daily tools, bringing broader benefits. The immediate impact is convenience and efficiency. AI handles tedious tasks like spam filters and automatic bill payments, giving us back time. AI acts as a universal assistant, smoothing modern life. Beyond convenience, AI is a force for accessibility, breaking down barriers for people with disabilities. AI-powered apps read text aloud, describe objects, and identify colors. Live captioning makes videos accessible to the deaf and hard of hearing. The benefits extend into healthcare. AI analyzes medical scans, spotting diseases with expert accuracy, leading to earlier diagnoses. In drug discovery, AI analyzes data to identify new compounds, speeding up the process. AI creates new jobs and augments human capabilities. It provides artists with new tools and democratizes opportunity. It's less about replacing humans and more about giving them superpowers. AI isn't all serious business. A huge part of its integration is purely for entertainment and fun. This is where we see the creative and sometimes even the weird side of machine learning. Take AI-powered photo and video filters on social media. When you use a filter, you're using a sophisticated AI model that identifies your face in real time and overlays digital effects. Then there are AI art generators like Midjourney or DALL-E, allowing anyone to create stunning images by typing a text prompt. You can ask for an astronaut riding a horse on Mars, and the AI will generate it in seconds. In gaming, AI creates smarter, more dynamic opponents that learn from your playstyle and adapt their strategies. Recommendation engines also bring delight. When Spotify introduces you to your new favorite band, that's AI creating a moment of joy. AI, while beneficial, presents challenges and questions we must consider. One concern is bias. AI learns from data, and if that data is biased, the AI will amplify those biases. Another challenge is privacy. AI systems thrive on data, raising questions about data ownership, usage, and security. The impact of AI on jobs is another ongoing conversation. While AI creates new roles, it also automates tasks, causing job market shifts. Finally, there's the challenge of explainability. Many AI models are complex, making their decision-making processes opaque. In high-stakes situations, we need to know why AI makes certain decisions. Developing transparent and explainable AI is crucial for building trustworthy systems. We've journeyed from ancient dreams to complex algorithms. AI is a vast field, and machine learning teaches computers to learn from data. This technology curates our entertainment, enhances our photos, navigates our world, and understands our commands. It's reshaping our world, and we're only at the beginning. You don't need to be a programmer to understand AI. It's about patterns, learning, and predictions. Understand the invisible intelligence in your apps. This digital literacy is essential. Be an informed user and engaged citizen. This technology has challenges, bias, privacy, and transparency. Conversations need to include everyone. Be curious and ask tougher questions. An informed public ensures responsible AI development. AI is a tool. Its impact depends on how we use it. The future of AI is not predetermined. Remain curious, keep learning, and think critically. And that just about wraps it up for our deep dive into the world of artificial intelligence and machine learning. We've covered a huge amount of ground today, from the basic definitions and the fascinating history, to the real-world applications and the big-picture impact. I hope we've managed to pull back the curtain a bit and show you that this isn't some unknowable magical force. It's a human-made technology full of incredible ingenuity that is built on surprisingly intuitive ideas. My goal was to spark your curiosity, and I hope you leave this video feeling more knowledgeable and less intimidated by the buzzwords that are all around us. If you found this video helpful or interesting, and you made it all the way to the end, first of all, thank you. It means a lot. And second, it would be a huge help to the channel if you could give this video a thumbs up. It really helps the YouTube algorithm and AI we've been talking about to know that people are enjoying the content, and it should show it to more curious minds out there. And if you haven't already, this is your final reminder to hit that subscribe button and ring the notification bell so you don't miss our next adventure into the world of tech. We have so many more topics to explore together. We are living in a truly remarkable time. The pace of technological change is faster than ever before, and technologies like AI are at the very heart of that acceleration. It can feel like a lot to keep up with, but remember that every complex system is built from simple ideas. By taking the time to understand those fundamental building blocks, you can stay on top of the trends and feel empowered rather than overwhelmed. The future is being written in code, and learning to read even a few sentences gives you a powerful new perspective on the direction our world is heading. Thank you once again for joining me on Tech Curiosity Stream today. I truly appreciate you spending your valuable time with me to explore this fascinating subject. I hope it has answered some of your questions and maybe even sparked some new ones. That's what this channel is all about. We'll be back soon with another stream to break down another piece of the tech puzzle. I can't wait to see you then. See you in the next video. Until then, stay curious.